So let's pick up where we left off. We were just doing a few exercises on this list of words from this this giant book, and the next exercise was supposed to be make a dictionary, which is just a sorted list of distinct words. That's an easy one. We have sorted set class, so we'll make a sorted set of so we'll call that a sorted word set. And that is a sorted set, and it's a tree set. Oops. Like so. And for each string in our word set, we add it to the sorted word set. And that gives us a sorted list of words. And let's just print maybe the first 20 of those. And of course, should be a new tree set. And let's test it. So we want to print from the sorted word list. Sorted word set. So there are the first few words in that set, and they're kind of boring because they actually turn out to be numbers. These are probably page numbers that got pulled out of the book. There's an empty string and numbers that start with 0, numbers that start with 1, and a few that start with 2. So the first little bit of that set would be boring. Let's try and look something up in that set. So let's do maybe we look in our sorted word set. We'll take a tail set, and we'll take the tail set that begins with everything that is greater than FRE. Okay, and let's print the first 20 words that start there. And if we want real words, we could also do everything that starts with A. Print that from TS1, and everything that starts with FRE, just so we can jump into the middle, and that's TS2. And there we go. So the first set of bunch of real words we get are aback, abandon, abandoned, abandoning, and so on. And starting with FRE, the first word that is greater than FRE is freak, then it's free, freed, freedom, freeing, and so on. Okay, so the next exercise then is to find the most frequently occurring word. Now, for that we need something more than a set or a list. The best thing is a map. And what we would like is a map that takes words as keys and maps those onto integers, where each word maps onto the number of times that it occurs. So we'll make a map. Its keys are strings and its values are integers. So let's call that just freak for frequency counter. And so that's a new hash map. We saw that those perform well. Now we want to go through the entire list of words including duplicates, of course. And now each time we look at a word, we need to see if it's the first time that we've seen it, or if we've seen it before. So if we've seen it before, then that key, which is that word, will already be in the map as a key in the map, in which case it already has a value associated with it, an integer value, the number of times we've seen the word prior to this occurrence. And so we want to do at that location, we want to put the old value plus 1. So we get the old value, we add 1, and that's the new value that we put there. Otherwise, we've never seen this word before, so that means we want to put associated with the key s, this new word that we're looking at, we want to put the value 1 because it's the first time we've seen it. Okay? And now we want to go through and find the most frequently occurring word. So we want to go through everything in our map. So that is for a string s in, so we want to go through all of the keys in our map. That's the key set of the map. And let's say two things to keep track of. One is the best frequency, which will start with 0, and the other is the string, which is the best string, which we start out as empty. Now, if the current word that we're looking at has a frequency, so a count, which is bigger than the best we've seen so far, then we update the best we've seen so far. And of course we save it. And once all that is done, the thing that we should have is the most commonly occurring word. If there's ties, then the first one that we happen to come across is going to be the winner. So we'll write the word and then maybe the frequency with which it occurs. Let's see if that compiles. We forgot a plus sign there. Of course it's not S, it's best S. So the most frequently occurring word in that text really unsurprisingly, is the word the. It occurs 17,718 times. Okay, and now let's finish up with the last of these exercises. And this one is kind of advanced, not because it's so difficult conceptually, but it's just awkward to do in Java. So it asks us to find the top k most frequently occurring words. So like maybe the top 20 most frequently occurring words or something. And we already have all the information that we need for that. We have a map that takes words onto the number of times that they occur. It's not a sorted map, and making it a sorted map wouldn't help anyway, because sorted maps are sorted by key, so that just means that the words would be sorted alphabetically. So instead we want to take that map, the key value pairs, and copy them into an array, and then sort that array by values. So let's start by copying that into an array. And if you look at the documentation for a map, there's something in there called a map entry. So these are the things that appear in a map, and it's just a pair of things, a key and a value. So let's go through. In our map, we will look at all the entries, and those entries are of the form string keys, integer values. So for each entry in my map, in this case, the map is called freak, so what we want is the entry set. So this will iterate through each of those entries. We'd like to add all of those things to a list of all the entries. So we'll make something like a entry list dot add me. And what's an entry list? Well, an entry list is a list of map entries. So it's a list. Each thing in the list is a map entry. So we might as well make it, since we want to sort it, we'll make it an array list. Okay, so by the time this is done executing, we should have everything into a list. Now we want to sort it. So we saw earlier in this first part of this lecture that there's a collections.sort, and collections.sort takes a list, and ideally it's an array list, so let's give it the entry list to sort, and let's see what happens when we try and compile that code. Okay, so it says there's an error here, not a statement. List, map, entry, string, integer. Entry list is a new array list. We forgot the name of the variable, me. No, not me. We want it to be called entry list. There we go. Good. And now we get a really complicated error message that says no suitable method found for sort in collections.sort, and it tells us the list of collections methods called sort in collections that might work. So one of them should take a list of things which is blah 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 comparable. So if we want to call collections.sort with only one argument, just a list, well, it has to know how to sort the things in that list, and that means that the things in that list have to implement the objects in that list have to implement the comparable interface, which means they need to implement the compare to method. And map entries don't do that because it's not clear how you would want to sort map entries. But we have our own way that we want to sort it. We want to sort it not by the keys, but actually by the values, the integer values. And we actually want to even sort it in decreasing order so that the largest ones come first. So map has, or collections has a couple of sort methods. So one of them is the one argument method that only takes a list it's supposed to sort. But there's a second sort method, and it's difficult to read here, but it explains what it is. It takes a list and a comparator. So what's a comparator? A comparator is a special class, a special interface, in fact, that only has one method in it. It's called the compare method, and it should be able to compare two things. So this is where we're going to use a fairly advanced Java feature. We're going to make a little tiny comparator class in line here that does comparisons exactly the way we need for this sorting. So the syntax for that is strange, but we'll do it. If it bothers you, don't worry too much about it. You don't have to memorize it, but just know that it exists. And if you ever find yourself in a situation where you need to do something like this, you can always come back and look at this video, or just look for anonymous classes in Java, which is the feature that we're using here. So a comparator is another one of these generic classes. You have to tell it what sort of things it's supposed to compare. And in this case, the things that it's supposed to compare are map entries. And not just any map entries, but map entries whose keys are strings and whose values are integers. Okay, so that is the kind of comparator we want. And the anonymous class syntax says we can, right now, right in here, we're defining this class. It has no name. It doesn't have a particular name because we're only going to use it once. We're going to make one instance of it right here. So all we need to do is define its methods. And to be a comparator, all it has to do is define one method. It's public, it's an integer, and it's called compare. It should take two map entries. A and it needs to compare them and return a value which is negative if A should come before B, and it's positive if B should come before A, or it's 0 if A and B are treated as equal, so it doesn't matter which one comes before. So remember, the things we want to sort on are the integer counts of these things. So in a map entry, that's the value. So we have B's value, and we have A's value, and if A is bigger, so A occurs more frequently, then it should appear first in the sorted list, which means we need to return a negative value. And the other way around, if B is bigger, then it should return a positive value. And we can actually get that just by subtracting the value of B from the value of A. If B is bigger, this thing is positive. If A is bigger, this thing is negative. So we just want to return that. Now that was a lot of syntax. Let's see if it actually compiles. I'm glad I have bracket completion here in my editor. Okay, so it says there was a thing expected. right there. I forgot a closing angle bracket. All right, so that compiled. And if all of that works, then by the time this runs, the entry list should be sorted. And its entries should be sorted by a decreasing frequency. So let's take a look at it. We have this method called first n that will print the first n things in any list, or any collection actually. So the entry list, and let's print the first 20 things. All right, it compiles, that's hopeful. And if I run it on Varney, eureka. Here's the output of that final line. It's a list of these entries. The first one, the most commonly occurring word, and this agrees with what we figured out already, is the. The next most commonly occurring word is and, with 9,996 entries. Then to, with 9,838. Of, I, you, that, he, it, in, was, has, be, not, have, his, is, said, for. So all really common words that you would expect to be sort of the top 20. So there's how you can do all that. And notice the speed of this thing, right? This is a book with 330,000 words, and this thing runs basically instantly. Really no time at all. 1/3 of a second to do all the stuff that we did here. Okay, so that's it. That's all I want to say about the Java Collections framework and examples of it that I want to show. So next class, we will actually start on the real meat of this course, which is understanding how these things are implemented efficiently, and sort of the mathematics behind it, and the general techniques behind it. We're going to step back and get away from Java and Java syntax and just look at the general techniques that apply for every programming language that you might do data structures in.